Hello, Math 45 students. We're going to continue on page 8, section 4.3, Fitting Linear Models to Data. A scatter plot is a graph of plotted points that may show a relationship between two sets of data. Take a look at the scatter plots below. Can a linear relationship be made about either? So here, remember that linear relationship, if you're thinking about the equation, that's the y is equal to mx plus b. And a line can either be positive, it can be negative, or it can be constant, okay? So positive, negative, or constant. So those are going to be the three different linear equations that we have talked about before: increasing, decreasing, and constant. So here we are talking about crickets chirps in 15 seconds and the temperature. So is there a linear relationship between crickets and the temperature? That means, do we hear more crickets when the temperature gets warmer? Okay. Well, if you want to draw a linear line or a linear equation, so notice how I drew a line. It's pretty much close to all the dots. It doesn't go through all of them. So there could be a trend. It suggests that the number of crickets chirps increases as the temperature increases. Okay. Now let's look at the graph below. Let's see if there's going to be a linear relationship here. Is there going to be a linear relationship between final score versus age? So if you're older, are you going to do better on your final exam? Versus if you're younger, are you going to be better on your final exam? So notice if I were to draw a line through these points, notice how these points are very far away from the line, okay? Because that's true, we say that there does not appear to be trend between age and final exams here. So it doesn't matter how old you are. Your final exam score is not dependent on how old you are, which may be a good or bad thing depending on how you look at it. So what we want to do, instead of saying, oh, there could be a linear relationship or there could maybe not be a linear relationship, we say there's a correlation. The correlation tells you how much strength of the possibility of a linear relationship. So notice how the strongest relationship here is 1. Okay, that means for sure, there's no doubt in telling me that that is a line. Also, -1, right? So +1 and -1, it just means it's a positive slope and a negative slope. So those definitely tell me there's a linear equation. Now, if it's just random and there's really nothing you can tell, that's going to be a 0, meaning it's just all scattered all over the place. So there's no linear relationship here. Okay. So, like I said before, the correlation value, we denote that as the value r, okay? And it has a range between -1 and 1. So r greater than 0, meaning it's positive, and r less than 0, meaning that's going to be negative, okay? All right. So let's look at this example down below. It says, which is the best estimate of the correlation coefficient r for the plot of data shown? This is for sure, if I were to draw a line through this, it hits every single point. So this is definitely going to have a correlation of 1, okay, or at least really, really close to 1. So now I have to determine, well, is this a +1 or a -1? Well, let's look at the slope. The slope here is positive. And you want it really close to 1. So what value is going to be the closest to 1? Well, it can't be negative. It's not 0. So by process of elimination, my answer is going to be r is equal to 0.99. Okay. Now let's look at the second example. if I were to draw a line through this, there's my line. It hits pretty much all of them. Maybe there was like one or two that didn't quite get it. And again, the highlighter is very thick, but that's okay. So we know this is definitely going to be a linear relationship. That yellow line pretty much has all of the dots on there. But you just want to make sure if your slope is positive or negative. Your slope here is going to be negative. And it's really close to 1. So it's really close to a -1. So it's not positive. So those are taken out. And it's not 0. So the closest one that's the closest to -1 would be this one down here. Okay. And now here, for this example, I'm like, okay, I'm going to try to draw a line. If I draw a line, there's a lot of data that does not hit that yellow line. So I can't even say that it's positive or negative. It would be very random. So I'm going to say that my R is 0. It's just very scattered. If I look at this last one, I'm like, okay, I can kind of see what's going on. Maybe here. So I do have some points, and it looks like the M, if I'm looking at it, it's going to be negative. It's going towards the bottom. And it does have some points, so it's not quite 0, but it's not all of the points, so it's not close to 1. So the best possible solution here would be R is equal to -0.54. So really it's just a process of elimination when you're trying to see which is going to be the best guess here. Now it says, for this example, which of the following plots below share a linear relationship between y and x? Circle all or select all that apply. So this first one doesn't really look like it's a line. If I were to draw a line, it doesn't hit anything. If I draw a line here, that definitely looks like it hits most of it, so that's going to be fine. And if I were to draw a line here, that doesn't quite work out. If I were to draw a line here, it doesn't quite work out. This is more of a curve. See that curve? And then for this last one, if I were to draw a line, it does hit some of this. So I am going to say that this is going to be okay. So for this page, the top right and the bottom left are both graphs that show a nice linear relationship. And if you wanted to keep it consistent, if I were to draw that graph with a yellow line, okay? So notice how those don't hit very well. Okay? All right. So now, remember, you have an extra unit for this class because you are required to understand a graphing calculator. So we want to find a linear equation that best models scatter plots with a linear relationship. So here are our directions listed on this page. So it says, use a graphing calculator and the table provided to do the following. Sketch a scatter plot of the data provided. So you want to copy it from the calculator. So I'm like, okay, here are my x and y values. So this is what I'm going to do. I'm going to bring up my calculator. So the first thing I want to do, so it even tells me, right? It says to create a scatter plot, okay? So it says press second scatter plot to use plot 1. And we want to make sure that all of that is highlighted. We also want to make sure that we put x in L1 and y in L2. So for our x1, that's going to be L1, and for our y, that's going to be L2. Okay, so I'm going to go to Stat. So I go to Stat, then I go to Edit. That's going to give me my L1 and my L2 values. Notice how I had some values in there. So all I did was I went up and I press clear, and then you go back down, and it clears everything instead of deleting it one by one. So my values are for x 0, 1, 2, 3, 4, and 5. So those are all of my x values. Now my y values, like I said, go into my L2. So that's going to be 4.78. I also have my 3.82 and a 6.71 and a 7.01, 9.56, and a 11.09. Okay. So now that I have all that information in there, I want to make sure that my scatter plot is on. The easiest way to do this is go to the y equals button. So up on top, see that y equals? We're going to go ahead and press that. Y equals. Notice how that plot is not shaded. So if I go up and then I press enter, then the plot 1 is shaded, which is perfect. That's exactly what I want. Okay? So then after that, I'm going to go to zoom, and I want to go to zoom stat. We are creating a scattergram, right? So that stat word is kind of almost built in. It's really a scattergram, but you can think of it as a stat, right? You're entering stats and you want to view that window. So now I'm going to press graph. So I'm going to try that one more time. So zoom. And zoom stat. There we go. Okay. So now I have my zoom stat on here. So notice how I have these points, right? So that first one is right on the y-axis, and then I have some kind of going on in a line. So I'm going to go ahead and copy this onto my paper, okay? So just remember, I'm going to be copying this screen onto my paper. It's not going to be exact, but that's okay. It looks like I had a box over here and another one maybe down here. Okay. So more or less, it kind of looks like that. And then it says for part B, does the data fit a linear trend? Well, if I were to draw a line through this, it definitely hits most of that. So I'm going to say yes. It definitely fits a linear trend. Then for part C, it says, hey, find a linear equation to model the data round to the nearest hundredths place if needed. Okay, so I'm going to go back to my calculator, and it's going to go ahead and calculate the linear regression. So I am going to go to stat. After I go to stat, I'm going to press my arrow button, and I'm going to go over to calc. So now under calc, this is linear regression. So I'm going to go down until I see that linear regression. Number 4, lin reg, ax plus b. So that A is really your slope, which is the m value, okay? And B is still your y-intercept. So now that I'm there, I'm going to press enter. And it says, hey, for your x values, do you want L1? Yes. For your y values, do you want L2? Yes. So I'm going to go down. And once it's on calculate, I'm going to press enter. So there's my enter. So now I have my values. And remember, we are rounding to the nearest hundredths place. So that's 2 places past the decimal. So I'm going to get my equation as y is equal to 1.40x plus 3.66. Okay. So just so you can compare it, right? That a value was really my m. and my B value 3.66 because that 5 got rounded up. Okay. Now we're going to do the next example together. So for this example, it says we're going to use this table, and again, we're going to sketch a scatter plot of the data. So I'm going to go back to my calculator. So I'm going to go back to Stat. I'm going to press Enter, and I'm going to clear my value. So I'm going to go up, press Clear, go back down. Then I press Over, go back up, press Clear, go back down. So all of my X values go into L1. So I have 1, 2, 3, 4, 5, 6, and 7. Now for my Y values, I have a 4.59, a 4.99, 6.74, 7.72, 8.92. Ooh, that's one too many twos, isn't that? That should really be 8.92. There we go. Always check your answers, or what? Always check your data, right? And then 10.17, and then 10.37. Okay, so I'm just going to take a couple of seconds here just to make sure I wrote everything right. And notice here I have 999, so that's one too many nines. So that should really be 4.99. This is a touch screen computer, so it's really touchy and really sensitive. So I always want to make sure I wrote everything correctly. So 4.59, 4.99, 674, 772, 892, 1017, and 1037. Okay, perfect. Now I've double checked everything. So now I'm going to graph the scattergram. So zoom. I'm going to go down to zoom stat. And then from there, I'm going to press enter. So now that's what that looks like. So it looks like I have 1, 2, 3, 4, 5, 6, 7 dots, and they all seem to have that linear equation. So I'm going to do my best to copy this onto my piece of paper. So this looks like it was like this, more or less. I guess that's pretty close. I guess this one is a little bit more in line versus this one was a little bit more down below. And it doesn't have to be perfect, but you want to just get the general idea. So there's my general idea. And then for part B, it says, does the data fit a linear trend? Well, it definitely looks like a line. If I were to even attempt it, I get pretty much all of it or really close to it. So I'm going to say yes. Fits linear trend. So now for part C, it says find a linear regression equation to model the data, round to the nearest hundreds. So again, I am going to do the linear equation. So on my calculator, I'm going to have to go to Stat, press the right button, Calculate, and I'm going to go down to Linear Regression. So this is where I press Enter, and I just keep pressing Enter. And now it gives me my value. So remember, I'm rounding to the nearest hundred, so that's 2 decimal places. So my slope should be 1.07. So y is equal to 1.07x. And if I look at my b value, if I'm rounding to the nearest hundredth, that 4 tells me to leave that 7 alone. So I'm going to have plus 3.37. So that is going to be the linear equation that models this data. Okay, so it looks like we have one more. we just want to make sure that you guys get the idea of how to do this. So practice makes perfect, right? So I'm going to go ahead and enter these values. So I'm going to go back to my stat. I'm going to press enter so I can go into edit. I'm going to go up and clear it. Oops, let's try that again. Then I go over, up, and press clear. Now my x values start at 2. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now for my y values, I have a 9.58. I also have a 7.46 and a 9.28 and 11.58, 14.94, 14.97, 18.43, 18.04, and 20.42. I'm just going to take a couple of seconds to make sure that my data matches. Okay, well, it looks like I've inputted everything correctly. So I'm going to go ahead and go to graphing it. So the way you do that, remember, you go to zoom and you go to zoom stat. Press enter. So that is my data. So it looks like the first one is a little above, and then the second, third, and fourth kind of are aligned perfectly. So I'm going to try to do that the best I can. So I did the first three, and then the fourth one aligns, and then maybe the next one goes up or down. And then it kind of swiggles a little bit. Okay. So, you know, I'm sketching a data. It doesn't have to be perfect. But does this fit a linear trend? Absolutely. So it definitely fits a linear trend. And I also want to make sure that I get my linear regression. So on my calculator, I'm going to go back to Stat, Calculate, and I'm going to go down to my linear regression. So I press enter, press enter again, and I get that my slope is 1.61316666667, right? So for this one, remember, you're rounding to the nearest hundredths place. So my slope is going to be 1.61. And that b value, since I'm rounding to the nearest hundredths place, should be 4.18. Okay. So now for part D, it's slightly different. It says using regression, or using the regression, find the value of y at x is equal to 13. So that means I'm going to plug that value in. So y is equal to 1.61. That 13 that I'm plugging in is for x, plus 4.18. So again, I can do this on my calculator. I have a 1.61 times 13, and it's going to be plus a 4.18. And if I press enter, I get that 25.11. So that would be my value of y when x is equal to 13. And that is the end of chapter 4. So if you guys have any questions, please feel free to email me. Thank you.